Without further ado, I'd like to introduce our first contestant. From entering the ring from Team Grad School, we've got Miss Chelsea setting the bar high Cunard from the Lancow Lab. And she's going to talk to us today about something entitled Attack of the Invasive Plants. Can they ever be stopped?
Woohoo.
All right, Chelsea, take it away.
Thank you. When you think of invasion, the first thing that probably pops into your head is aliens from outer space. But when I think of invasions, I automatically picture plant species from this planet. Although we may think of different things, alien and plant invasions do have some things in common. First off, when alien and plant invasions both require the movement of the species into a new area from its native land. Second, when aliens and plants invade, they become the dominant species in the community and cause all sorts of problems. Invasive plants can alter ecosystem services like decreased pollution mitigation and local biodiversity. For my dissertation, I decided to study the invasive plant over the alien because they're a little less scary and easier to find. I have chosen to study an invasive grass, Japanese stilt grass, and whether it's able to maintain being an aggressive invader through time. Scientists think that one reason why certain plant species are able to become invasive is because they escape their specialized pests and pathogens. In the native range, these pests and pathogens, like insects and fungi, are able to stabilize the population. But when these plant species move into their invasive range, they escape these specialized enemies, and this allows for explosive population growth. However, it's unclear for how long this actual release from enemies can last for. It's quite possible that these enemies can catch up to these invaders, either by coming from the native range or developing in the invasive range. In my research, I will explore whether this invasive grass accumulates soil fungal pathogens through time, and whether this can be related to a decline in the grass's health. So far, what I have suspected is supported by my data. I have found an increase in mortality at older invaded sites, and this is correlated with the change in the fungal community in the soil. Although I still have some work to do to figure out whether this change in the fungal community is actually pathogen related. This research is really important because understanding how invasion plays out through time can actually help in management goals. If invaders are becoming less aggressive through time, then the problems they are causing are probably decreasing as well. So targeting the younger populations would be ideal for managers. So although I'm not saving the planet from alien invasions from outer space, by doing my research, I am aiding by a large impact on real-world plant invasions. Thank you.